Hello everyone, my name is Omnisha Kumar and today I will walk you through the concept of converting an infix notation to a prefix notation. So the first thing we will learn is what exactly is an infix and a prefix notation. So by definition, an infix notation is the conventional notation where operators are placed between the operands. For example, a plus b. Here, plus is the operator and a and b are the operands. In a prefix notation, it is also known as the Polish notation. Here, the operator is placed before the operand. For example, plus and plus ab. This shift in the operators eliminate any need for parentheses for easier, operation order, and also it is read easily by the computer, so it enhances computational efficiency. Now, the importance of conversion. Why exactly do we need to convert an infix expression to a prefix expression? So by converting it, it aids in removing any ambiguity. It does not need any parenthesis, and it's also easier for machines to understand the prefix expression. It is also used in compilers, parsing, and reverse engineering. The applications of infix and prefix. So infix notations are used in mathematical expression evaluation in any programming languages such as Java, C, and in expression editors. And in prefix notations are used for expression evaluation in any stack-based programs or machines, in LISP functional programming languages, in artificial intelligence and logic systems, in abstract syntax trees. Now, the advantages and disadvantages of infix notation. The advantages of an infix notation are it is human readability, familiarity, ease of writing, compact representation. So here, infix expression we it's the way we write any mathematical problem, so it's easier for us humans to understand it. It is familiar for us and it is easy to write because it is familiar, and the representation is by our value. It is, good. Disadvantages: ambiguity without parentheses, difficult for computers to evaluate. It is not suitable for stack evaluation. It is error prone for complex expressions. Now we will see the advantages and disadvantages of a prefix notation. Here, the advantages of a prefix notation it does not need parentheses. It is suitable for computers. It is well suited for compilers and interpreters, and it is consistent evaluation order. So a prefix notation is easier for computers to understand, hence it is easier to evaluate and it is suitable for compiling any given program. So the disadvantages of a prefix notation it is less intuitive for humans. It is harder to write manually. It is poor readability for long expressions, and it is not common to use it daily. In disadvantages, as we are more used to infix notations, it is less intuitive for humans. We understand it less. It is harder for us to write, and we cannot read it as fluently as we read infix expressions, and it is not used daily. Now we see how to convert an infix expression to a prefix expression step by step. So the first step to convert an expression is to understand its operator, precedence, and associativity. So here is a table which shows the level of each operator, its precedence and associativity. For example, here the addition and subtraction is operator is in the lowest precedence, and in the next level, on the higher level, is the multiplication and division operator, which is high, and it's also from left to right. Then on the highest level, comes the brackets, the exponential sign, which is of highest precedence, and this associativity is from the right to left. It's like the previous slide itself. Here you identify the operators, the operands. Is it in to see which one we need to use first according to the operator precedence. Now we have for step 3 we have to reverse the given infix expression. So we reverse the infix expression and it creates a new sequence which is the postfix expression, and then after converting it to the postfix expression we apply the operator precedence rule. And in this, we rearrange the operators and operands and we group it according to the precedence level. This ensures the final prefix expression and it reflects the order of operations. Now we see the flowchart for conversion. So as I said before, we started with the infix expression, we take it, then we reverse the infix expression and we stress. Then if there are brackets, we swap the opening bracket to the closing bracket and closing bracket to open bracket. Then we convert the expression to a postfix notation. Then the postfix notation will, after putting it according to its operator precedence and associativity, we convert the postfix expression, we reverse it, and then we get our prefix expression. So now we will see some solved examples of converting an infix notation to a prefix notation. So the first example is A plus B into C. So now we take this infix notation, we see which has the higher precedence. So according to our table, operator precedence and associativity table, the operator has a higher precedence than the addition. Hence, we first group B and C. So first we take the sub-expression of the infix B into C and convert it according to our precedence level. Now it becomes multiplication BC. Now we come back to the original expression with our prefix notation to it. So now it's A plus in bracket into BC, and now this whole expression we convert it into our prefix notation, which is plus A into BC. Here is a visual example with expression. So this is the original infix expression, then we reverse it. We swap the brackets as there is no brackets. We convert it to the postfix notation, then we reverse the postfix notation and we get the same answer as it is here. There are two methods. You can use whichever is easier for you. It's either according to your precedence level, or you can use the converting of infix to postfix and then postfix to prefix. It's according to your comfortability, and yeah. Now we see another example, which is A in bracket A minus B divided by C. In this, you evaluate A minus B first as it has parenthesis and because it is the highest level of precedence. So A minus B becomes minus AB and followed by our division symbol. So when we convert the whole thing into a prefix expression, it is divide minus ABC is the final answer. So here it's also a visual representation. So you identify your sub-expressions first, which is A minus B, then you convert the inner parenthesis to prefix format. Then you apply the division and place it before the previous result, and then you get your final prefix notation. Now here is our visual representations in a stack. So we take the example of A plus B into C minus D. Here, it's the same way you reverse and swap the parentheses and you convert the expressions in the bracket first, and then you take the whole expression and convert it. So after doing that, our prefix notation is into plus AB minus CD. Now here is our stack representation. Now we will go to our next example. A minus B divided by C. So this is the same example we've used in our previous slides. So same thing. You evaluate A minus B first because it's according to the parenthesis, then you divide it by C. This is our stack representation, and our symbols go first because it's according to parenthesis, then A, then B, and then we get our final answer. Coming to our next slide, we will see a program to convert an infix expression to a prefix expression. So now we start with our header files, which is include stdio.h, ctype, our define max. Define max 100 is the maximum size of an expression. Then we go to our character stack, which is an array to simulate the character. Then top is the index value. And then we push a character onto the stack and increment it. Then we remove and return the top element of a stack and then return the element without popping it. Then we see using int is operator. We see if C is an operator, and that is our. And then after that, we assign its precedence and precedence to the operators, and higher number is equals to the highest precedence. Then to reverse a function with the bracket swap, we use void reverse. So in this, we reverse the array manually, which also swaps the brackets with each other, which is used in reversing infix to a prefix annotation. Next, to convert infix to prefix conversion, we use temporary, which holds the postfix results temporary, which the postfix results which has to be converted to a prefix result. And the length calculates the string length manually. Then we use reverse infix and swap the brackets. Now coming to the main conversion loop. For I is equals to 0, I less than len, I plus plus, which is used to process one character at a time. And then if is num c is an operand a minus a to z and 0 to 9 to copy the result. From else if c is equals to open bracket and all that, it handles the bracket push open bracket, and when it's seeing the when it sees the close bracket, and pop until it sees the open bracket again. Now, else if is operator C, it is for operators. Pop from stack to result if stack top has higher or equal precedence, and then we push the current operator. The while loop is used to until the loop ends for the pop remaining operators from stack. Then we reverse the postfix result to get prefix and null terminate the string manually. Then we copy the results into the prefix array. Now int main, we declare arrays for the users, and then we read the characters using get character until an expression is enter is pressed. Then we replace new line with null character to terminate the string. Then after that, we convert and print our expression to get our output. Now here is our output for a given example. So I took this example itself and we get our output. Thank you.